Yo, 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 what's up, guys? Let's take a trip. Now, today we're going to talk about color. But first, we have to talk about light, because color is something you see, and you don't see anything when there's no light. So, light is made up of tiny packets of energy called photons. Photons travel at the speed of light, but they also vibrate as they move, or oscillate. The number of vibrations a photon makes every second is called its frequency. Now, these photons vibrate at different frequencies, from 400 up to 750 trillion oscillations per second. Now, the retinas of our eyes have millions of tiny photon detectors, called cones. When these cones detect photons, they react by sending signals to our brain. There are three types of cones. Let's just say they're called Team A, B, and C. Team A can react to lower frequencies, Team B reacts to medium range frequencies, and Team C can react to higher range frequencies. Now, why do particular objects have particular colors? Let's take a strawberry, for instance, made up of chemical compounds that absorb photons of most frequencies, but it contains no compounds that absorb photons that oscillate at about 500 trillion times per second. So these photons are reflected, enter your eyes, and react strongly with the cones in Team A. When this happens, the signal is sent to your brain, resulting in seeing red, by a complicated process that is not yet fully understood. Now let's take a lime. A lime contains different chemical compounds than a strawberry. It absorbs photons at frequencies below 500 and above 600 trillion oscillations per second, and reflects enough to excite the cones on Team B, resulting you to seeing green. A blueberry absorbs most photons, but reflects those that oscillate enough for Team C to react, so you see blue. Now, there are some objects like sugar cubes that reflect most photons at all frequencies. When these photons enter your eyes, all three teams react strongly and produce a signal called white. Now, a banana peel, for example, is within range of both teams A and B. This combined signal does not result in seeing red and blue at the same time, but however, a new perception, yellow. Different objects reflect different combinations of frequencies, which result in all of the colors we see in the world. Some estimates have humans being able to distinguish between several million colors, but it is important to remember that objects in light by themselves are not themselves colored. Color is a mental perception. You see color because of the way your eyes and brain are constructed. Color is actually a special effect created by our brain and eyes. Digital cameras and smartphone cameras don't even actually record or save color. They save wavelength and intensity information of received light by each pixel as a numerical code. Even our color TV doesn't produce colors, but instead produces light in the red, green, and blue wavelengths. Our eyes take this information to quickly process, then these signals are brought to the brain for further processing. Our brain then interprets these wavelengths of light as different colors. In other words, our brains are constantly at work painting everything we see. To put it simply, colors do not physically exist outside of our minds. They are just waves or a code that our eyes and brain are able to decipher. And that's what I got for you guys today. Till next time, yo, 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 let's take a trip.